The introduction of the Fatek PLC software WinproLadder. So let's come on the software. This is a new file, new project. You have to make a new project. So if your PLC model is changed, simple, you have to open the new project. This is the model name. First you have to give your project name. This is the introduction lecture. So this is a model number. You have to select your model according your PLC. I am selecting FBS minus and point is 24 and model is MA. Okay, select OK and OK. Now this is a workplace file programming, and this is a file. In this you have to make a new project. If you have already a project, you can open from this command open, and these are saving commands. If you want to import and export your ladder diagram, import table, you can do by this commands. Okay, and these are printing options. In edit, is the cut, copy, paste, is a like same other software. And if you find any project, you can control F3 or F3, you can use these commands. If you want to replace any command, you can replace the command. Okay, and this is a view. In this view you can program your in ladder diagram or project tree. If you want to do in ladder diagram, you have to select ladder diagram. Okay, and this is your font. If you want to change the font of your command, your comments, you can change the, if you want to biggest, you can, the font is big. If you want to choose font large, medium, small and teeny. So mostly medium is perfect size. Okay, is the toolbar. If I close this project, you can hit one window, one bar is close, it disappear. So I will go to again view and select the project. This bar will come again. So same way they are 1, 2, 3 and 4 bars, toolbar. And this is a project. In this is a IO configuration. If you choose timer, counter, high speed counter, the interrupt setup, this is the output setup, input setup, temperature configuration, all configuration you can do this. Okay, and in project is the memory allocation. By this you can see the retentive coil numbers, and you can see the timers. If you press OK, it will show all the X, Y, your input output memory ranges. You can see by this command. This is a ASCII table, link table. When you make the server programming, you have to choose server parameter table. This is a Modbus master table. When you communicate your PLC with other device by Modbus communication, then you have to use this table. The register tables. Okay, the status page is a comment. When you want to show the comment on the input output, you have to choose the comment from here. And this is a ladder. This is your all the contact A and B, your coil set is all programming tools. You can choose from this, and you also can use from this bar. Okay, and it's a PLC. In you want to do a programming to your PLC, you have to select the online. If you want to do simulation without the software, without the PLC, you have to select this simulation. Okay, and it's a run and stop the PLC. These are all the very basic things you have to learn. You can see these are comments like I will make a one rung program. This is the input, and it is the x0. This is our input, and I will show the command like this is the input 1. Okay, and this is our output y0. Again is the output 1. Okay, it's a simple one rung program. In this way you can make all the logic. In future lectures I will give the complete introduction of the input, outputs, memory registers, retentive register in the future lecture. Okay. Hello friends, today our topic is very important and basic of the PLC, the wiring of the PLC. Today topic will be carrying 3 questions. First one is the difference between NPN and PNP sensor. And second question is Fatek PLC hardware wiring. And last one is difference between PNP and NPN wiring. So let's start the lecture. First one question is difference between NPN and PNP sensor. As we know, there are 2 types of the sensor available in the market. First one is the NPN sensor and second one is the PNP sensor. NPN sensor always gives negative voltage of 24 volt during operation. And second one is the PNP sensor. PNP sensor always gives positive voltage during operation. And you can see in the picture, this is a 3-wire PNP and this is a 3-wire NPN sensor. And there are 3 wire of the sensor. This is the color of the wire is the brown, black and blue. In brown wire you have to get plus 24 volt is the supply of the sensor, and blue you have to give the 0 volt of the 24 volt. Is the both wire brown and blue is the supply of the sensor, and black is the output of the sensor. If this is the PNP sensor, then output will be positive. You can see the positive sign. And this is the NPN sensor, same wiring, brown color for plus 24 volt and blue wire is the for 0 volt of 24 volt. This is the supply of the sensor, and black wire always gives the output of the sensor. This is the if NPN sensor, then output will be negative, and if PNP sensor, then output will be positive. These are different between PNP and NPN sensor. You can see this is another example of the sensor. This is a BN mean this is a brown, BU mean is a blue, and BK is a black wire. And you have to give the plus volt at brown wire and negative volt as blue wire, and you will be get a multimeter. If the output is positive, then this is the PNP sensor. If output is negative, then this is the NPN sensor. Okay. Now, Fatek PLC hardware wiring. Sensor are 2 types, so Fatek PLC wiring also 2 types. So we, according to our sensor, we have to do our wiring. If we purchase the PNP sensor from the market, then we have to do PNP wiring. And you can see this is the plus and negative voltage of the PLC. First you have to give the 220 volt supply at L and N. L is the line voltage and is the neutral. Then your PLC will give plus and negative volt at this point. Okay. If you want to do PNP wiring, then you have to connect S/S pin with negative 24 volt. You can see this is a red wire. You can see this is a yellow color wire. Is the internal wiring of the PLC. All the point of input is connected with S/S. If you give the negative volt to S/S, then all wire will be connected with negative wire. Okay. And this is a PNP sensor, you have to give the supplies plus 24 and negative 24. So this is a negative 24 volt, not positive. Okay, and this is a plus 24 volt. Okay, so your PNP sensor will be give plus 24. So negative volt is coming from this circuit and plus come from PNP sensor. Your input will be on. Okay, this is the PNP wiring of the Fatek PLC. This is the wiring of the output side. This is the C0 common for Y1 and Y2. This is a common one for Y3, Y4, Y5, and this is a common 2 is the for Y6 and Y7 as soon. Okay, if your PLC is the relay type, if you give 24 volt, then your output will be give output is 24 volt. Okay, and if you give the negative to be a 20 volt to the your actuator, then it will be on by. Okay, now this is NPN wiring. If you have the NPN sensor, then you have to do NPN wiring. In NPN wiring, you have to connect the S/S point with plus 24 volt. Okay, you can see this is the internal wiring of the PLC, is a yellow color. Okay, so I take the two example NPN sensor, and you have to give the supply plus 24 volt and negative 20 volt to the PNP sensor. When NPN sensor will give the output, it will be negative, and internal circuit is positive, then your input will be on. Okay, and this is your output side, same like PNP wiring. Line and neutral gives the 224 volt to the PLC for supply of the PLC, and the common 0, common 1, common 2. If you give the 24 volt, then your Y1 and Y2 will give the 24 volt when your PLC give the on the output. If it is the relay type PLC, then you can use the 220 volt also. Okay. If you have any question regarding this lecture, you can raise a question in comment box. You also can the message on our WhatsApp number. Okay. Hello friends, in this lecture I will tell you about the input output dressing and the how many range of the input output data registers, memories, counters, timers in the PLC. Simple, you have to go to the file and create your new project. I am using FBS and 0.24 and model is MC. Press OK. Give the project name IO's dressing, because this is a lecture on IO dressing. Input output, I for input or for output dressing. It's a very basic thing. Okay. Now you have to go to PLC. So the project and go to memory allocation and press OK. You can see this is the all ranges of input, output, relays, timers, counters. Okay, so first one is the input contact, and you can see this is a total 256 input, and X0 is the initial input, first input, and last one is X255. And same for output relay is the output coil, and the range is in front of you, Y0 and Y255. This is the last one, total 256. And in future I will tell you about the relay. There are two types of relay, retentive and non-retentive, and this is also internal relay of non-retent. Okay, so in the future I will tell you about the difference between retentive and non-retentive, but you can see the ranges. Okay, and M0 to 799 is a total 800 non-retentive relays. This is a step relays, and this is a timer. You can see that your timer is 0.01 second from T0 to T49, a total 50 timer of 0.01 second, and this is a 0.1 second timer is from 50 to T199, total 150 relays, timers. And you can see this is a timer of 1 second, this is a count of 60 bit, this is a count of 32 bit, all are ranging in front of you, and you don't need any manual anything, just you have to see from your software. All the data register are, this is a D data register. In future I will tell you all the items and working and difference between the items. So in this session I will tell you about the input output addressing. Simple, you have to go to this bar, this is a toolbar of ladder, and press your input and drag here, and simple press X0. If you want to give the some comment, then you can say this is the sensor 1, press OK, and if you use X1, press here, and this is sensor number 2. Okay, and this is the output coil. Simple press here and drag here, and this is our Y0, and you can hear this is the motor, output motor 1. Okay, and select horizontal short. Simple press here, it will complete your run. Okay, and if I use B contact here, and you can, this is a X3 and sensor 4, and go to the vertical shot and press here. Okay, this is a very simple. In this way you can do your input output addressing. Okay, now you have to go to the PLC and go to simulation. If you don't have your PLC and you want to check your program, to get simple, you go to simulation. Okay, and run the PLC. Okay, this is the off. Okay, and if you want to on this, and on this, your input motor is on, output motor is on. If you off this, but it's still on because your path is there. Okay, so in this way you can do your input output addressing. So go to PLC and end the simulation, and you can use memory. Simple, use output, the memory M0, and you can, this is a set output, this is a comment, and simple, okay, sorry, and go to the simulation, and this is give you the alarm. We have to remove this. Okay, now you go to the simulation. Okay, and it's already forcefully on. Go to the PLC and run the PLC. Okay, now you disable, off the input. Okay, and if I on the input and this input, you can both your output is on. This is a memory bit and this is the output bit. Okay, memory bit means it has the internal memory of the PLC, and this is the external output you can take from the PLC wiring of output, but is the internal of the PLC. Okay. Hello friends, today our topic will cover 3 questions of the Fatek PLC. It is a very basic question of the programmer. What is the memory bit and data register in the Fatek PLC? Second one is the how many type of the data register in Fatek PLC. And last one is the what are ranges, memory bit and data register of Fatek PLC. So in this lecture we will cover 3 questions. And we also do practical in the software. Now, first one is the what is the memory bit and data register in the Fatek PLC. Memory bit is a symbol is M. It's also called internal relay. It's word like same as output, but internal relay can use only in software during programming, but cannot use in hardware like output. So its behavior like same output of the PLC, but we cannot use its hardware. Like in output of the PLC, we can use as a hardware, we can connect the wires with the output. But in memory bit, we can use in only programming. I will do in practical in software in this lecture. Second one, the data register. Its symbol is also D and R. It's used for moving and storing the process data in PLC. If we want to store any data like any numerical value, we can use this data registers. Second question is how many type of the data register in it Fatek PLC. As other PLC, Fatek PLC have retentive and non-retentive data register. Okay, there are 2 type of the data register. One is the non-retentive and one is the retentive. In retentive data register, data will not lose if PLC power off. If during programming, during running of the PLC, if power will be off, then this type of a register will not lose its data. It will store its current data. In non-retentive data register, data will be lost if PLC power off. Okay. We can change the spelling. Retentive is also called retentive. Okay. Now last one is the what is the range of the data register and memory bits. Range in given software. Let's see on the software. We will move the software. WinproLadder is the Fatek PLC software. Go to new project. We will choose FFBS 24 points is our PLC model. This is the memory bit. And data register. Topic. Okay. Now first I will tell you about the ranges. Go to memory allocation and press OK. Our last question is the what are ranges of the data register and memory bit. So I will tell you in software. You can see this is the internal relay. Is also called memory bit. Okay, and there are three type of the internal relay. First one is the retentive. This is a retentive. It can store the value and don't lose the value if power will be off of the PLC. It is from M800 to M1399, and this is the internal relay from 0 to 799, and it total 800. It is a no retentive. It can lose its value when your power of the PLC will be lose. The special relay is that relay in which designer has a specific values. These are step relays, and other what is data register is the R. Okay, this is a data register, and you can see R, D both are data register. This is a retentive data register, and this is a no retentive data register. Okay, now I will make a program in which I will use memory bit and also data register, and in this programming I will tell you about the how to use memory bit and how to use data register for moving the data. So first I will take input x0, x1, x3 and x2. Okay, use the vertical and use memory bit M0. Okay, now again M0, this is our memory bit, same like output, and one input more x5. Again I will use M1. Okay, now I will take M1 as the input, and now I will use function command, and this is a move MOV and press OK. This is a moving command, and we can move the data from one place to another place. S means this is the source, and D means is the destination. So I will let 500 I want to move to data register R1. Okay, I use move command and move the data move the data 500 to R1 data register. Okay, and another M0 input and M1 also as an input, and go to function, use the MOV command, function, sorry, I will delete this one. No, take the function again, I place here MOV, like I will move R1. We can use the data register in source and move the data R7. Okay, now in this program I am using memory bits. I have stored the all this condition to only M0, and this memory logic have to save in M1. So by these two logics, two memory bit M0, M1, I can use any other logic, like I am moving the data from source to destination. I am moving the data from S1, S is the source, 500 to R1, and in this I am moving the data from R1 to R7. Both are data register. So go to the PLC and go to simulation. Okay, I will open the status, new page, status page, and I want to monitor R1 and R2. Okay, already in R1 having 400 value. Okay, and R2 has a 0 value. Sorry, I am have used R7, so I will place it R7. Both are data register. Okay, now I will on my inputs. Sorry, go to run the PLC and go to in on. Also on this, your M0 is on. Okay, this memory bit is on. Now I will on the X0 also, sorry, X5, and you can see is M1 also on, and all the conditions okay, and 500 it moved to R1. You can see 500 is moved in R1 data register, and second condition is the value of R1 is moved to R7. So R7 also has a 500 value. So in this way we can use the data register, and memory bit is a very important in programming. If you make the very in industrial point of view, when you make any complex program, then you have to use memory bit. Is very useful item, and move command you can move the data from any data register to another data register. Okay, if you have any question in this lecture, you can raise a question on the comment box. Okay, bye. Hello friends, today we will learn very important and useful command in Fatek PLC. This command will help you to make complex logic in very easy way. First one is inverse command. This is a positive edge trigger, and this is a negative edge. This is a set, and this is a reset. We will learn 5 command. Okay, first one is inverse command. This command behave like NOT gate. It will change 1 to 0, 0 to 1. In other words, yes to no, no to yes. We will do this programming. Let's start new project. Select your PLC. This is FBS 20 and MC. And project name is useful commands. Okay, now you have to take input and X0 and one output Y0. Okay, now I will use one inverse command. I will click here and place here. You can say this is a symbol. Now compile and run the simulation and run the PLC. You can see this time your input is off condition, but your output is on, because this is a inverse command. If I on this input, then it will be off the output. Okay, so by inverse command your value will be changed from 1 to 0 and 0 to 1. Okay, so by using this command you can make the very complex logic by simple way. Okay, this is the working of the inverse command. No, next one is positive edge. Is a picture. You can see when value change from 0 to 1, your positive edge will work, and this is a negative edge. When value move to 1 to 0, it's called negative edge. Okay, we will change this. First we stop the PLC and stop the end simulation. Remove this command and place horizontal shot. Choose up power flow and pick here and place here. Okay, now compile the program, simulate and run. Okay, now you can see just I will on the input only very short second your output will be on, because this time your input value is 0. When it move to 0 to 1, this your up edge will be work. You can see this value is on for very short time. Again I off the input, nothing is happen. Again I on the input, you can see this output is on very short time. So again off your input and go to stop the PLC. Now I will replace by down edge. It also called TU power flow. Okay, now again run the PLC. Okay, you can see this time when I on the input, then nothing's happen because it's from 0 to 1. When I move to 1 to 0, it will be on very short time. Yes, it's on very short time. This way we can use this positive and negative flow power flow. Okay, no, I will go to the stop the PLC and delete the this rung. Okay, now I will take one input x0 and will use set. This is a function and I want to set the y0 input. Okay, and one more function set D0 is a data register. Okay, and again I will use x1 and set the reset y0. Reset the D0. Okay, now you have to run the PLC and open the status page y0 and D0. Okay, when I on the input, you can see, and of the again input, still your y is enabled, is a set, and d0 is also has decimal -1 value. Okay, is a set, both values are set condition. Now I want to reset this both y0 output and d0 data register, then I have to press x1, otherwise it will be not reset. If I again on off, nothing is happen, but I on the x1, value will go to 0, f y0 go to off, and d0 will to give the value 0, is a reset position. Again I set the input, you can see this is a enable position, is a set points, both the output is set, but for reset I have to press this x1. So this way we can use the set and reset the command of the Fatek PLC. If you have any question regarding this lecture, you can raise the question in the comment box. Okay, bye. Hello friends, today our topic is timer egg counter. Timer egg counter are backbone of the PLC programming. You must have to learn the timer egg counter for doing perfect programming. First one is the timer. There are three types of the timer in Fatek PLC. First one is the timer of the base 0.01 second. Second one is the timer of base 0.1 second. And last one is the timer of 1 second. Three timers are available in the Fatek PLC software. You can use any software according to your project and your logics. In this lecture, I will do the practical in the software counter type. There are two types of the counter, 60-bit counter and 32-bit counter. 60-bit counter have the range from 0 to 32,767. This is the maximum value of the counter. If you want to count the more value from 32,767, then you have to use 32-bit counter because it has a very large value. Okay. 60-bit counter more divided into two types. One is the retentive counter and second one is the non-retentive counter. Retentive counter will not lose the value when power of PLC will be off. And non-retentive counter will lose the value when power off of PLC. 32-bit counter is range from 0 to is very large value. You can count very much big value. 32-bit counter more divided into two types. One is the retentive and second one is non-retentive. Retentive counter will not lose the value from PLC if PLC lose the power. But in case of the non-retentive counter, it will be lose the value when power of the PLC is off. Now let's start the programming practical. Start your file, go to file, create the new project. Project name is timer counter. A PLC series is FBS. It's 20 and model is MC. Okay. Now go to project and open the memory allocation. You can see there are three types of timers is in front of you. First one is the 0.01 second. The timer range from timer T0 to T49. 0.1 second timer range from T50 to T199. And 1 second timer ranges from T200 to T255. There are three timer and its ranges. Now counter. You can see there are two types of counter, 16-bit counter and 32-bit counter. and mode is retentive and non-retentive. This is the ranges of the counter C0 to C139. This is a 60-bit counter and retentive. And from C140 to C199, the counter is 60-bit but is non-retentive. From C200 to C239, this is the 30-bit counter retentive. And last one is the non-retentive from C240 to C255. Okay, these are ranges and total counters. Let's start the programming of the timer. X0 and timer T0 is the 0.01 second. So if I want to take the delay of 10 seconds, then I have to multiply 1000. It automatically gives the 10 second delay. T140 is a 0.1 second. If I multiply it by 100, it will give the 10 second delay. T250 this is a 1 second delay. You can see 1 second base time. If I put the value 10, then it will give the 10 second delay. So there are three timers of the different base time, but every timer will give 10 second delay. Put here short of horizontal and vertical for complete the circuit. T0 T140 and last one timer 250 and one coil Y0. Okay, and I also use status page right here, timer 1, so timer 0, timer 140. It will show the value of the timer in this page. Timer 250. Okay, now go to the PLC, go to the simulation and run the PLC. Okay, you can see this time the value of the 3 timer is 0. When I on the input, 3 timers start to count the delay. After 10 seconds, 3 timer will be on. You can see. So this way we can use any timer according to our logic and project. Okay, when I off the input, again all the timer go to 0. Okay, this is the timer of the 1 second base time. This is the 0.1 and this is the 0.01. Okay, in this way you can use any timer. And go to the stop PLC and stop the end simulation. Now we will use the counter. Put X0. Now I will take 3 counter, 16-bit counter, 32-bit counter, and one is a non-retentive counter. So first one is C0. This is a 60-bit counter and retentive counter. Its value will be not lose if PLC power lose. And if I put the value 32,767, it is acceptable value for 16-bit counter. But I increase the value, it will be go to red color. Mean to say this is a not acceptable value because this is a 16-bit counter and its value maximum 32,767, not 8. Okay. Now other counter C100. Sorry, I will check in PLC memory creation. Okay, no retentive is 140. I will take 140 and 32-bit counter. I will take the value 200. Okay, 140 and 200 counter. So I take this one 140. This is a no retentive 60-bit counter and any take value. Okay, no, I will take 32-bit counter. Sorry, 250, and you can see if I put the value 32,768, it is acceptable. In this case, in 60-bit it is not acceptable, but in case of 32-bit it's acceptable. I give any value, very big value like this, you can see is acceptable because the range is very high. Now use shorts for completing the circuit. Delete this one and add this. Okay, and this is a it will clear the your counter value. So I also take one input for giving the demo of the how to clear the counter value x2 and use horizontal short. Okay, and use counter 0, C0, C140 and C250. Okay, it very already 1, so I will go to its value already 1. Then I have to use delete this one and go to x1 for clear the counter. And delete this one. And use any other input x0, sorry, x0, x1 and put here x like 0 and x0 and x3. Okay, and use the horizontal short. Its value x0. Here I will use one more input like x7. I use horizontal. Okay, first we will count the counter and clear CL or clear the counter value. So go to the simulation and on the PLC. Okay, go to there. Now I off the inputs and I will clear. This time counter 0 has the 2 value, and I press the x1, its value is 0. It's a clear the counter value. x7 value 0 and x2 is clear the counter value. Now when I on the PLC input, you can see 3 counters start to count the value. Again give the any other pulse, it's going to counting the value. Now when I off the PLC from run mode and again run the PLC, you can see first I have off the input. Now you can see current. Okay, only counter 0 has the 4 value and other counter value go to 0 because this is a retentive counter C0 and C140 and C250 is a non-retentive counter. When I off the PLC from run mode to stop mode and stop mode to run mode, the only C0 value is stored 4 and other counter is go to 0. If you have any question regarding this lecture, you can raise a question in the comment box. Okay. Hello friends, today our topic is addition, subtraction and multiplication and division in Fatek PLC programming. So let's start in software. Go to file, open new project. This is our project is addition, subtraction, multiplication and division, and select the our PLC model FPS 0.20 F model MC. Press OK. OK, start. So I will take two data register for adding the addition, subtraction and division and multiplication. So first I will take input x0, go to function and I will use incremental circuit, incremental function and use D like 10. Okay, and again I will take increment command and D12 and complete the circuit by adding horizontal and vertical shorts. Now again I will use one input mode x1 and function of move data movement. I will move initial value like like 50 at D10. And 100 value like 100 value at D12. Okay. Complete the circuit. Now I will take no addition and subtraction and multiplication and division command. I will go to function and ADD addition. I will add both data register D10 and D12. So first one is D12 and D10. It should move in D15. Okay. SA is the one value, SB is the second value, and both results should be saved in this D15. Or now I will take other function subtraction subtraction. Again I will use D12, sorry D15, sorry D12 D10, and this one should be saved in D20. And other one is multiplication. D12, SB is second, D10 should be saved in D25. And same way I will use one more function. This is a division, div. Okay, this is a division command, and D12, D10, and should be saved in D30. Okay. Now take one input M0 and complete the path. Now take the vertical shot. It all the complete the enable input of the function is an enable. When value will be go to enable, this function start to work. Okay. Now you have to take status page, okay. Now first one is D10, this is the data register. Now for D15 will carry addition result, D20 will carry subtraction result, and D25 will be carry multiplication result, and D30 carry division result. Okay, as we make the function, you can see D10 D12 is a both register, D10 and D12, and D15 will be carried addition result, and same way subtraction, multiplication and division. Okay, now go to compile simulation and run the PLC. Okay, this time every data register has 00 value. Okay, I will on the x1 will move the value 50 to T10 and 100 value to D12. So I own the x1, you can see this time D12, a D10 and D12 has a 50 and 100 value. When I own the M0, then every function of the mathematic functions will be enabled and start to work. So I own the, you can see 50 plus 100 is equal to 150, 100 minus 50 it will be 50, the D20 will be carry subtraction result, and when I multiply 100 to 50, then 50,000, sorry 5,000 will be result of the multiplication, and D30 is the result of the subtraction, sorry division. When I divide 100 by 50, it will be 2. So now I will start to increment these two data register D10 and D12 start to increment by +1. So I own the, you can see I have to off the x1. Now you can see it continues adding the value, and this is the result of the addition, subtraction, division and multiplication. Okay, so in this way you can do your programming according to your project, according to your logic. Again I move the this value 50 and 100 and of the input, and when on the incremental function start to increment and value is in front of you. Okay, so I off the this one. In this way you can do your mathematical function in programming. If you have any question regarding this lecture, you can raise a question in the comment box. Okay, bye. Comparison command in the Fatek PLC programming. This is a very important and useful lecture today. Mostly command is equal, less than, greater than the values. When you are playing the numerical value in the programming, you may use this command for comparison the numerical values. Please go the function and write here, and this is a compare. You can see the compare. When you click the compare, you can see this is a equal, less than, greater than, less than, and less than and greater than, and this is a less than and equal and greater than. This is all the command of the comparison. You may use any command and according to your logics. So let's start this command. First take the any input x0 and go to function, press here and simple go to the compare command and click on the equal. I put SA D1, this is the one value, this is the one data register, and D2, this is the second value data register, and use any output Y0. Okay, this is a very simple run, and I will go to new page and status page. I will write here D1 and D2. I will put the value 0. First you have to go to the PLC on simulation and run the PLC. Now you have to put a 00 value here, D1 and D2. Okay, now when I on the input, our Y0 is on because D1 and D2 both have the equal value 0 0, because it's an equal comparison command. When I put D1 the 2 value, now your output is off because both value is not equal. Again I put D2 2 value, then again your output is on. Okay, so this way you can use the comparison command. So I again put a 0 values and go to the stop PLC and the simulation. We will make one program for use all the comparison command. Okay, so right here x0 as the input and use function command equal D1 and D2. Okay, and vertical use another function, use less than, is a greater than, like D1, again D2, same data register, and I will complete a circuit by, and one more function less than, again same D1 and D2, and I will complete the circuit. I put here vertical short. So these are 3. Now I will take one more. This is the less than and equal, both equal and less than, D1 and D2. And complete the short circuits. And one more, this one, D1 and D2, and complete the circuit. Okay, now take outputs Y0, Y1, Y2, Y3 and Y4. Okay, and complete the circuits. Okay, this is a very simple program. In this program we will learn the how to use this command and its working outputs. Okay, so go to PLC and go to simulation and run the PLC. This time first I will on D0, D1, D1 and D2 values. This time D1 and D2 register has the 00 values, and you can see only Y0, Y3, Y4 is shown because Y0 is the equal command. D1 and D2 is equal, so it is on. And Y3 is on because D1 and D2 has in this run equal and less than. Because this is the equal, then both is on. Y0, Y3 and Y4 because both command has the equal, also equal and less than and greater than. So I will change the value. I put the value D1 5 value. Now Y0 is off. Okay, and Y2 and Y3 also off. Only Y1 and Y4 is on because Y1 has greater than command. This is size the greater than. D1 is greater than to D2, so this Y1 is on. And same greater than D1 is greater than to D2, so this Y4 is on. I again put D2 5 value. Then same condition as before, both values equal, Y0, Y3 and Y4 is on. And when I increase the value of D2, like D2 is 8, then Y2 and Y3 is on because this has a less than value. D1 is less than D2, so Y2 is on, and Y3 has the same command. D2 is less than to D2, then Y3 is on. So in this way you can use your comparison command according to your logics. And if you have any question regarding this lecture, you can raise a question in comment box. Okay, bye.